Two-dimensional vectors, Level 3. In this video, we're going to go over various examples and practice applying the concepts from the previous videos. Before we start solving problems, let's first go over one final concept associated with the magnitude of a vector. In addition to finding the component form of any directed line segment, we can also find the magnitude by simply finding the components of the vector and using the distance formula. In other words, the length, or magnitude of a vector v, is found by taking the square root of the vector's x component squared plus the vector's y component squared, as follows. We now have two distinct ways to find the magnitude of a vector, and both involve the use of the Pythagorean theorem. If a directed line segment is represented by an initial and terminal point, we use the first formula. If the vector is represented in component form, then we use the second formula. These two formulas are very similar to each other. The only difference is the way in which the vector is described. One formula uses coordinate points, and the other uses the components of the vector. You should be comfortable using either one. In some textbooks, the magnitude or length of a vector is also referred to as the norm of the vector. Lastly, the magnitude of a vector is equal to 0 if and only if vector v is a zero vector. Alright, let's go over a couple of examples. Find the vector from the point 1, -2 to the point 3, 7. Okay, here we are given the coordinates of point A and point B. We're asked to find the vector that starts at point A and ends at point B. In other words, we are asked to find vector AB. To find the components of this vector, we essentially need to take the coordinates of the terminal point, in this case, point B, and subtract the coordinates of the initial point, in this case, point A. We need to make sure that we subtract the terminal point from the initial point, or else we will obtain a vector that points in the opposite direction. Carrying out the subtraction, we obtain the following. Vector AB is equal to 3 minus 1 for the x component, which simplifies to 2, and 7 minus -2 for the y component, which simplifies to 9. So the vector that starts at point A and ends at point B can be represented as vector AB, with components 2, 9. Alright, let's try the next example. Find the component form and length of the vector v that has initial point 3, -7 and terminal point -2, 5. Okay, let's first plot the initial point and terminal points so we can have a visual representation of the vector. Let's label them as point A and point B respectively. Then we go ahead and draw a directed line segment from point A to point B as follows. Let's first find the component form of the vector. In order to accomplish this, we need to find the x and y components of the vector. We can find the x component of the vector by simply taking the x coordinate of the terminal points and subtract the x coordinate of the initial points. Doing that, we obtain -5 for the x component. In the same manner, we take the y coordinate of the terminal point and subtract the y coordinate of the initial point. Doing that, we obtain 12 for the y component. So the component form of vector v is represented as -5 and 12. Having found the component form of the vector, we now find the magnitude of the vector by simply taking the square of each component, adding them, and then take the square root of the result. Doing this, we obtain the final answer equal to 13. This means that the length of this vector is 13 units long. Alright, let's try the next example. Find a vector v with representation given by the directed line segment AB. Draw AB and the equivalent representation starting at the origin. Point A is -2, 2, and point B is 3, 0. Similar to the previous example, we're asked to find a vector v that is represented by the directed line segment with initial point A and terminal point B. In order to find the vector, we need to calculate the vector's components. So we go ahead and take the coordinates of B and subtract the coordinates of point A, making sure we subtract them component-wise. Doing that, we obtain the following. Vector V is equal to 3 minus negative 2 for the x component, which simplifies to 5, and 0 minus 2 for the y component, which simplifies to negative 2. So vector V has components equal to 5, negative 2. Now that we have the components of vector V, we go ahead and draw an equivalent vector with initial point located at the origin. This is also referred to as a vector and standard position. Drawing the vector, we have the following. Vector V starts at the origin and terminates at point 5, negative 2. Notice that the terminal point of a vector in standard position has coordinates equal to the components of the vector. Okay, let's try the next problem. Find the component form of the vector V and sketch the vector with its initial point at the origin. In this problem, we are provided with the graph of a vector, along with its initial point and terminal point. We are asked to find the component of this vector. Similar to the previous examples, all we need to do is take the coordinates of the terminal point and subtract the coordinates of the vector's initial point. Doing that, we have the following. Vector V is equal to 3 minus 3 for the x component, which simplifies to 0, and negative 2 minus 4 for the y component, which simplifies to negative 6. So vector V has components equal to 0, negative 6. Now that we have the x and y components of the vector, we can go ahead and draw it in standard position. Notice that this vector has an x component of 0. This means that it only has one component, in this case, the y component. So vector V will be pointing in the negative y direction. So we start at the origin and extend the vector to the point 0, negative 6. This vector is now in standard position. Alright, let's go over the final example. Find the vectors u and v whose initial and terminal points are given. Show that u and v are equivalent and find the magnitude of the vectors. Alright, the problem is asking us to find vectors u and v. We are provided with the vector's initial and terminal points. They are essentially asking us to denote the vector in component form. Let's start with vector u. Similar to the previous examples, let's take the terminal point and subtract the initial point to obtain the components of the vector. Doing that, we obtain the following. Vector u is equivalent to 1 minus negative 4 for the x component, which simplifies to 5, and 8 minus 0 for the y component, which simplifies to 8. Alright, now we do the same for vector v and obtain the following. 7 minus 2 for the x component, which simplifies to 5, and 7 minus negative 1 for the y component, which simplifies to 8. Now that we have both vectors u and v in component form, we go ahead and compare their components to see if they are equivalent. Since the components of both vectors are identical, we conclude that they are indeed equivalent. Lastly, we go ahead and calculate the magnitude of the vectors by taking the square of each component and adding them together, making sure we take the square root of the result. Doing that, we obtain the square root of 89 as the magnitude of vector u and v. Alright, make sure you're comfortable with the component form of a vector. We will be using this form extensively throughout our studies of multivariable calculus. In our next video, we will learn various vector operations.